Hello everyone, my name is Weiwei.
And my name is Wei.
Nowadays we're interacting to current famous LLM model like GPT or DeepSeeks. We do not know what expert you are talking to and what material they are using to answer your questions. And furthermore, hallucination is a big issue we want to solve. And that problem is an inspiration to our project, which is called Hierarchical Expert Routing and Orchestration System, HEROES. And the system allows us to talk to an router who match the user to an expert with the most relevant material. And for our current semantic router framework, it requires the user to explicitly write down the representation for each expert, and that raises two issues. The first one is it's quite time consuming to create such utterance. And second, there's no way to ensure the utterance accurately represent the expert. And the design of this project is based on the vector representation of all the relevant materials. First, all the materials are vectorized and stored in ChromaDB, and the average of all material vectors represent the expert centroid. And to represent the group vectors, all the expert centroid are further averaged, weighted by the number of materials the expert contain. And when the user make a query to our systems, the cosine similarity between these questions and the group representations are calculated. And the group with the highest cosine similarity is selected. For example, if we ask what is Q-learning, it's highly possible the CS group will be selected. After a group selections, the same process is undertaken for all the experts in the group. And the selected expert fetch the relevant materials from ChromaDB and feed them into ChatGPT API to carry out in-context learning. After introducing the project's structures, I would like to highlight several of its technical advantages. The first one is the computational efficiencies. The two-stage hierarchy bring the time complexity from O(n) to O log n. And second, in contrast to the issue of common router framework, our system do not need to manually define the outers or label training data. This system can configure itself automatically, reducing the save-up time and human effort. And finally, as the knowledge bases evolve, the system's centroid automatically update to reflect the new knowledge, keeping the model to a model current without manual intervention.
Alright, let's get into the tech stacks we use in this project. So the entire code base can be roughly divided into the backend, the database, and the front end. For our backend, we use the fast API connected with LangChain and the program in Python. For the database, as we mentioned before, we utilize Chroma database, use sentence transformers to vectorize the tokens, and then we use Pydantic to structure the database schema. For front end, we utilize Vite, CSS for formatting the website, and then using React for functionality. For the program architecture, from left to right, first we receive queries from the user. We send the query to Fast API where all of the backend functionality are processed. We vectorize the query, send it to the semantic router, and then this is where the semantic router determines which expert is best fit for this query. Once we decided the expert, we send the query to our ChromaDB, select the database represented by the expert, retrieve the most relevant data chunks, and then we send it to OpenAI. OpenAI would compile the data chunks from ChromaDB along with a response, send it back to Fast API, and then send it back to our user. So this is the entire workflow of our program. Let's look at some demo to see how it works in practice. So let's start with the router itself. To test the accuracy of the router, we select total of 10 experts and a total of 250 samples. And then this is how it works in practice. So as you can see, all of the queries are sent to the router to do a testing. And then in the end, we achieve an overall accuracy of 90%. In total, 250 samples only takes around 5.7 seconds, which on average per query only takes around 0.02 seconds, which is incredibly fast. and improve the feasibility of our architecture, not just the efficiency but also the accuracy in the effectiveness. All right. And then now let's see how the router works, combining our database and our front end architecture. So on the left, this is our front end, and then on the right, you can see how it works in the back end. And then you can see we have two major groups, and then in the two major groups contains 11 experts. So let's clear the chat. Here we already prepared some samples to test for this demonstration. Let's start with physical activities. So if I just copy paste this line and then post it to our chatbot, as you can see on the right, we received a query from the chatbot, and then first we go into two major groups, which is the course material group and then the health expert group. So we compare the similarity score of the course material and then the similarity score for health expert, and then we can see health expert is a lot higher, 0.26 comparing to only 0.0015. So once we dig into health expert, we compare mental health and physical activity, and then we found out physical activity has a higher similarity score. So we retrieved the relevant documents from the physical activity expert, sent the chunks to ChatGPT, and then GPT send us the response. Yeah. So as you can see here, the expert is accurately selected, which is physical activity. Let's do a few more examples. Now let's do mental health. So we also select the mental health query, send it to the expert, and then the entire thing repeats again. We select the major group, and then the major group will select the corresponding expert, which in this case will be mental health. Yeah. Let's just do a couple more demonstration on top of the mental health experts. For example, if we want to ask about statistics for social science, we can also copy paste the query and then send it to the expert. Yeah. So now the expert is thinking. Yeah, it gives you an accurate response and then direct it to the corresponding expert. Yeah. The same for example, software engineering. Also, as you can see from the backend, the router itself is very time efficient. Yeah, most of the time taken are used to do an API call from OpenAI. Yeah. So I think this is quite enough for the demonstration. But in the end, let's wrap up the presentation with one of the queries from our course, which is reinforcement learning. So for example, if I'm the student taking advanced topics in AI and machine learning, and then want to ask about more of the course material, I want to learn how, what are the key components of Markov decision processes. I can also send it to the chatbot, to the interface, and then it gives you an accurate response by directing your query to the corresponding expert, which in this case is reinforcement learning. Yeah. So let's summarize the entire demonstration, and then I think that's it. Thank you very much. This is Wei, and then my partner Weiwei. And then also obviously special thanks to Professor Ross for his